All right, we're looking at section 13.8, part 2, and this is problem number 57, one of our optimization problems, looking for an absolute maxima and minima. So we are looking at f of xy equals x squared plus xy, and our region is xy such that the absolute value of x is less than or equal to 2. And the absolute value of y is less than or equal to 1. So let's make a sketch of this region. So here are my axes, just a quick sketch to help us visualize what we're talking about. Absolute value of x less than or equal to 2, absolute value of y less than or equal to 1. So we're in between. Just going to do it like so. So we're on this rectangle. And up here we have y equals 1. Down here we have y equals minus 1, x equals 1 there, and x equals minus 1 over here. And our vertices, this is negative 2, 1. Two, 1, 2, negative 1, and negative 2, negative 1. So there's our region. Let's look at the interior first. So on the interior, we're looking at our partial derivatives. We're looking for critical points. So we want to set our first partials equal to 0. So f sub x, partial with respect to x, 2x plus y. And that equals 0. And the partial with respect to y, which is x, and that equals 0. So already we know that x equals 0, and substituting that into our first partial, we have y equals 0, so we have a critical point at 0, 0. So there's our first critical point. And at 0, 0, plug 0, 0 into our function. F of 0, 0 equals 0. So that's the first point that we're interested in. This is one of our critical points. That's our point of interest on the interior of this function, on the interior of the region. So let's look at the boundary. We have 4 boundaries that we need to look at here. So let's start on y equals, I'm just going to start down here on y equals minus 1 on our boundary. On y equals minus 1, f of x, f of xy, our function is x squared minus x. I'm just substituting minus 1 in for y in my function. We want the minimum value of x squared minus x on this boundary. So for our minimum value, we're going to take the first derivative, f prime is 2x minus 1, and set that equal to 0. This gives us x equals 1/2. When x equals 1/2, and we're on the boundary y equals minus 1, so f of 1/2 minus 1 equals minus 1/4. And we also need to look at the edges of our boundary on each vertex to see if that gives us an extreme value also. So we're looking for the extreme value on a bounded interval, we have to look on the interior, and we have to look at the endpoints. So f of minus 2, 1, sorry, minus 2 minus 1 over here is 6, and f of 2 minus 1 is 2. So here are some points that could be, this could be our minimum. F minus 2 minus 1, that's the biggest value of f that we found so far. Let's look at our next boundary. We're going to look on y equals 1. So we're looking on the upper boundary here, y equals 1. We're looking up here. Our function f of xy equals x squared plus x. Just substituting y equals minus 1 into the function. We want the extreme value, maximum or minimum value on this boundary. So we're looking at f prime equals 2x plus 1, and we're setting that equal to 0. That gives us x equals minus 1/2. And we're on the boundary y equals 1, so f of minus 1/2, 1 is the point that we're interested in. That is minus 1/4 again. And we're going to look at the endpoints of this interval as well. So we're going to look at f of minus 2, 1. That gives me 2. And f of 2, 1 equals 6. Just plugging in and evaluating for the endpoints of my interval. So far our minimum value we found for f is minus 1/4, and the maximum value at a couple different points is 6. All right, we have two more intervals to look at. So we're going to look at our left and right, not two more intervals, two more boundaries. We have two more boundaries to look at. So we're going to look at the left-hand and right-hand side. So on x equals 2. So we're on our right-hand boundary on the picture that we drew. F of xy, just plugging in x equals 2 into our function. F of xy is 4 plus 2y. And we want f prime, when we take the derivative of this, f prime is 2, and that is not equal to 0. And we're going to look at our endpoints. F of 2 f of 2, 1. We found that one already. That's 6. And f of 2, negative 1. That's the other endpoint of the interval that's our right-hand boundary. F of 2 minus 1 is 4. And we have finally our left-hand boundary on x equals minus 2. F of xy. Plugging in minus 2 for x into my original function. F of xy is 4 minus 2y. And f prime, the derivative, is negative 2. And that doesn't equal 0 anywhere on that boundary. So we'll look at the endpoints. F of negative 2, 1 turns out to be 4. And f of negative 2, negative 1, we already found that one, is 6. So we found our critical points, and we examined our boundary. So our absolute minimum is minus 1/4. And we have a couple of points where that's true at 1/2 minus 1 and at minus 1/2, 1. And our absolute max is 6, and that is at a couple of points as well, at -2, -1, and at 2, 1.